Hello, welcome to Math with Minogue. Today we're going to talk through some tips, strategies, little calculator tricks, things to help you get a 5 on that AP Calc test. We're going to use the 2014 calculator FRQ. So let's get rolling. The table given represents selected values of time versus velocity for Ruth as she rides her bicycle along a straight trail. Our goal in question A is to approximate Ruth's acceleration at time equal 1.4. And we want to show all the computations. So first thing, we need to know the relationship between position, velocity, and acceleration. So acceleration is the derivative of velocity, or acceleration is the rate of change of velocity. I'm looking for the acceleration at a given point. Well, I can't really find the derivative if I don't know an equation, so I do the next best thing, and we're going to find the average, or the approximate rate of change. We're looking for 1.4, so I need to bracket the 1.4. So I'm going to go velocity of 1.6 minus the velocity of 1.2 divided by 1.6 minus 1.2. Simply y2 minus y1 over x2 minus x1, the average rate of change. Looking at my table, I get 16.3 minus 17.2 divided by, we can do that in our head, 0.4. Jump over to the calculator, and I get 16.3 minus 17.2. Hit equals divided by 0.4. And I get a negative 2.25. Show the computation that leads to your answer. Done. Indicate the units of measure. So this velocity is miles per hour. So this will be miles per hour or miles per hour squared. Okay, question 1. All done. 1A, all done. Question B. Use correct units to interpret the meaning of the integral from 0 to 4 of the velocity of d at t. Do it in context of the problem. So let's just find the answer, and then we'll use that to justify or to interpret. Now we're going to approximate the velocity using a midpoint Riemann sum. So I got to cruise back up here. Midpoint Riemann sum with 3 subintervals. Here's my subintervals. I'm going from 0 to 0.8. I'm going from 0.8 to 1.6 and 1.6 to 2.4. Those are the 3 rectangles for my Riemann sum. Remember, the height of the rectangle is the y value, or in this case the velocity, and the width of my rectangle is the width or the interval of my times. So in this case, what I see is an interval from 0 to 0.8, so I want to have a delta. They're all 0.8, which is nice. So 0.8 will be my width of my rectangles, and since they're all the same, I'm just going to put it out to the side. And I put a parentheses. My midpoint Riemann sum, what is halfway between the 2 endpoints, looks like the 0.4, and the y value at 0.4 is 11.8. Next subinterval, my midpoint is at 1.2, and the y value is 17.2. And the last one, the midpoint is at 20, and so my y value is 16.8. Grab my calculator, and I go 11.8 plus 17.2 plus 16.8. Hit equals, multiply it by 0.8. Answer 36.64. Okay, I'm gonna cruise up so we have more room. Check my answer, make sure we did it right. We're good. Now, the units on that thing. So what did we just do? We integrated a rate. When you integrate a rate, you get an amount. Or if I integrate velocity, I get amount traveled or distance traveled. But we gotta be careful what I just said. We get the change in position. In this case, though, notice there's a couple things they say. The velocity is greater than 0 for the whole entire function. So Ruth never changes directions, so this really does represent distance traveled. Not always. The integral velocity is not always distance traveled. In this case, since the velocity is always positive, I can say that 36.4 units would be miles. Ruth travels 36.64 miles during the interval of t is less than or equal to, I forgot the interval, 2.4? Oh, it's right above me. Okay. Units of time was hours. So Ruth travels 36.64 miles during the interval of 0 to 2.4 hours. That would be an interpretation. We showed all of our work, and so we're good to go. Question C. Ruth's velocity can be given by that function g. According to the model, was Ruth's average velocity during the time? What was Ruth's average velocity during the time interval? Being able to translate verbal descriptions into mathematical calculus notation, super important. Average velocity. My velocity, or Ruth's velocity, can be given by that equation. So average velocity would be the average value of that function. Since I know the velocity equation, I'm going to integrate 0 to 2.4 over 1 over 2.4 of the velocity equation. In this case, it's not velocity, it's g. Okay. Now, here's the first little calculator trick. Not really trick. Tip, I guess, would be a better way of saying it. I'm going to take that function and I'm going to type it in and I'm going to store it as g. Now I can do it two ways. I can use control equal sign to give me what's called a definition. It's an equal sign with a little semicolon after it. I'm going to show you a different way. I'm just going to go control division sign to give me a fraction bar. And on top, I'm going to go 24t plus 5 sine, where'd sine go? There we go. Sine of 6t. Jump down, and I have t plus 0.07. No, 0.7. I'm going to jump over here, and I'm going to go control, store that as g. Use function notation, g of t. Jump over, hit equals or enter, and it says done. Didn't do anything, it just stored it. Okay, so there's one way to store. Later in the video, we'll show a different way of storing. So, next thing, what I want, just type in that mess. So I'm gonna go, not control, I'm gonna go menu. I'm gonna go to number 4, calculus, number 3, integral, bottom is 0, top is 2.4. And now my function is just g of t. I don't have to retype it because I've already defined what g is. And I'm integrating that with respect to t because I use the variable t. It equals, and I get 33.75. Divide that by 2.4 because it's average value. And I get my final answer of 14.06. To 3 decimal places, 14.064. Double check that's good. Yep, my units. Average velocity, miles per hour. Okay, question number D, letter D. According to the model given in part C, is Ruth's speed increasing or decreasing? Speed increases when the velocity and acceleration have the same sign. Speed decreases when velocity and acceleration have different signs. So what do I need to know? At time equal 1.3 is the velocity and the acceleration positive or negative? That's what I need to know. Okay, so what's super nice about what we just did over here is now I can just find the velocity. Velocity we said was g. So g of 1.3 is my first thing I'm going to calculate. So g of 1.3 is 18 point. And I really don't care about the value. I just care about whether it's positive or negative. And so I'm just going to write that, which is greater than 0. The next thing I want is the acceleration, which is g prime. So I'm just going to find the derivative now. So I'm going to come over here. I'm going to go Menu, number 3, number 4, Calculus, number 2, Derivative at a point. My value is going to be t, not x. The value I want is 1.3. And the first derivative is okay. Doing d of t of g of t. If you like x's better, you can use x's. Evaluating at 1.3, hit enter, and I get 3.7, etc., which is also greater than 0. So giving a reason for my answer, since since g of 1.3 and g prime of 1.3 are the same signs, that implies the speed, or we could say Ruth's speed, not the speed. That implies Ruth's speed is increasing. Speed. If velocity and acceleration have the same sign, speed's increasing. If velocity and acceleration have different signs, speed is decreasing. Okay, just double check, make sure we got that good. Yep. All right. Question 2. A store is having a 12-hour sale. Total number of shoppers who have entered the store is given by that equation. There's no shoppers in the store at time equals 0. Super important to recognize that. Okay. Question A. At what rate are shoppers entering the store? Simple derivative, right? We know an amount, right? Total shoppers is what we're given. I want the rate at which that's changing, so we're just going to do derivative. I'm going to do the exact same thing we just did. So I'm going to go Control, and this little template button right here. Oh, sorry, I don't want to do that yet. Hang on. Delete that. I'm going to go S of t. Jump out of there. Now I'm going to do Control and that little template button where my cursor is pointing at. That says define S of t to be what follows. Okay, so I'm going to define S of t to be 0.5 t squared, nope, t to the 4th. Make sure you get out of the exponent, minus 16 t to the 3rd power, plus 144 t squared. And we're good. When I hit enter, it should say done. Okay, and now I'm going to, and that seems like, why would I do that? Why not just find the derivative? Because we're going to possibly use that later. Okay, now if you were taking the test, you may want to read question B or question C and see if you're going to reuse that equation later. A lot of times you do. So I would just type it in right away. So now we're going to go over here to menu and number 4 and number 2, derivative with respect to t at the value of 3. Jump down here, hit OK, and I want to find the derivative of s of t with respect to t at 1.3, and we get 486. Now, I want to show what I'm doing. So over here, I'm going to write s prime to show what I typed into the calculator of 3, and that equals 486. At what rate are shoppers entering and leaving the store? 486 shoppers per hour. Make sure you have units on there. Doesn't say justify, so we're good to go. Question B. Find the value of 1/3, etc. Use correct units to explain the meaning of that. Looks a lot like average value. 1 over b minus a from a to b of s prime. Okay, so remember, average value is the average value of whatever function you're integrating. Average value is the average value of whatever function you're integrating. So it's the average value of this s prime. Well, what's s prime? S prime is the rate at which shoppers are changing. So I'm integrating, or I'm finding the average rate at which shoppers are entering and leaving in the time interval from 6 to 9. Okay, let's evaluate that. So how do we do that? 1/3 integral from 6 to 9 of s prime of t dt simply equals 1/3 s of t evaluated from 6 to 9, which is simply 1/3 of s of 9 minus s of 6. Throw parentheses around that. That's not an integral symbol, sorry. Looks like an integral symbol. I'll write a little smaller. Right? Integral of a derivative is the original function. So this is just s of 9 minus s of 6 times 1/3. Well, that's pretty easy to type in. So I have 1 divided by 3, parentheses, s of 9, jump out of that first one, minus s of 6, jump out of that second one, hit equals, and I get 301.5. Rounding to 302. So, in context of the problem, I'm going to slide that. Whoops! I'm going to slide that answer over a little bit. Equals 301.5. So, on average, or shoppers enter the store at an average rate of 302 shoppers per hour. Okay? Make sure you explain using good notation and good units. Double check. Looks good. And I probably should say, I just saw that between the interval six to 9. Okay, now we're good. All right. Question C, the rate at which shoppers leave the store. So I'm going to do the same thing. I'm going to jump over here, use our little control, do that every time. I'm going to call L of t. Now I'm going to use control. I'm going to use the fraction button again. I like the fraction bar, not just the divide by symbol. I forgot my -80. Whoops. So we have -80 plus that fraction bar, and we have 4,400. We have t squared minus 14t. And again, if you like x better, you can use x. Calculator doesn't care. Plus 55. Okay, so I'm defining that to be L. Again, it says done. I didn't use capital. If you wanted to use capital, you can. I didn't feel like going through to change everything to a capital. According to your model, how many shoppers are in the store at this time of the sale ending? Okay, we got to be really careful here. S represents the number of shoppers in the store. at a given point in time. L represents the rate at which shoppers leave the store at any point in time. So the number of shoppers in the store is equal to the number of shoppers that enter the store minus the number of shoppers that leave the store. I guess I'll use capital, but in my calculator it's lowercase. We'll use capital here. The number of shoppers that enter, and the number of shoppers that leave. I must integrate my rate to find the number of shoppers. Okay. According to your model, how many shoppers are in the store at the time the sale ends? So this is going to be S of 12 minus the integral from 0 to 12 of L of t dt. And let's type it in. So I have S of 12. I'll do it individually. Lost my pen. And I get 3,456. And let's integrate. So I want to do menu, number 4, number 3, integrate from 0 to 12 of the function I just defined, L of t, with respect to t. Hit Control, Enter, and we get 3,260.3, which is just 3,260. We subtract the 2, so we get 3,456 minus 3,260 gives me 196 shoppers. Go back, read the problem. Make sure they don't ask me for any justification or anything like that. Give your answer to the nearest whole number, 196. Make sure they can read my writing. I would definitely make sure you have a calculus expression that represents what you're typing in. You're going to get points for that, most likely. I can't guarantee that, but most likely you're going to get points for describing your logic in calculus notation. Super important that we can do that. Okay, again, double check. Yes, 196. Okay, letter D. Using the given models, find the time at which the number of shoppers in the store is the greatest from the interval from 0 to 12. Okay, maximum value. I'm thinking extreme value theorem. Extreme value theorem says I want to check endpoints and critical values. Okay, endpoints and critical values. Critical values. Well, first of all, what am I looking at? Number of shoppers. Well, I just wrote that equation. The number of shoppers in the store at any point in time is the number of shoppers that enter minus the number of shoppers that leave. But now we're not going to 4. Now we're going to 12 of L of t dt. Super important that you show that there. Again, my S looks like an integral. Sorry, I need to write more precisely. Okay, so now I'm looking for critical values of that expression. So I'm looking for n prime, which is s prime, and the derivative of an integral is just L. I'm going to take that 12 out of there for a second so I can get my generic expression. Now I'm going to use a dummy variable inside, not outside. Does it really matter? Yeah, we do want to use good notation. Okay, so this will be L of t. Okay, using my dummy variable inside. Remember, these two variables, the upper bound and what's inside, have to be different. So that's why we picked the x. Okay, critical values. Let's solve. When is this expression going to equal 0? So I go over here to my calculator and I want s prime. So I have the derivative, menu, number 4, number 1, the derivative, sorry, I want to change. I want to solve. Sorry, going nuts over here. Number 3, algebra. I want to solve. And what am I solving? I'm solving, now I do derivative. Menu. Number 4. Number 1. The derivative with respect to t, because everything is defined as t. And this one's going to be my s of t. Okay, so I'm solving the derivative of s of t minus just L of t equals 0, and solve that thing not for x, but solve it for t. So the derivative of s minus L set equals 0, and solve for t. Looks good. I get several options. I get time equals 0, time equals 5.5, etc., and time equals 12.98. Well, my critical value is at 0 and at 5.545, etc., because the 12 is outside. So I want to finish writing this. Good notation. So this is going to be s prime of t minus L of t, and the answer is 0 equals t, and 5.5 4, 5, 0, 7, etc. 12.98 doesn't matter. So now I'm going to make a little table of values. Why did I put in 0 there? That would be a t. T and n of t, and I'm checking at 0, I'm checking at 5.54507, and I'm checking at 12. Okay, so first one's pretty easy. Integral from 0 to 0 is just 0, and s of 0 we already knew was 0, so first one's 0. And 12, so I want s of 12. Nope, s prime. So I'm going, no it was s of 12. I said it right the first time. So s of 12. Jump over, minus, menu, calculus, integral from 0 to 12 of L of t dt. And I get 196. Oh, we just did that one. Sorry, that was dumb. We just did that one up in question. No, that was D. That was D we just did. Or not D, but 12. 196. And now I want to do the exact same thing with the 5.5. So I want to redo that one, but I want this to be at 5.45. So I'm going to jump up here. No, I'm just going to type it. I could go up and grab it, but I think it's easier just to type this one. You want to make sure you have enough accuracy. 6, 7, 8 decimal places is fine. And this one is easy to type in instead of going up and trying to grab that. But if I had a big long mess, I'd want to go up and try to grab that. And this is 1,361.83. Max shoppers clearly at time equals 5.545. At which time? So they don't actually ask for the number, but at time equals 5.545 hours. There is a maximum of 1,361, technically 62 shoppers. Okay. All right. That is it for the practice test. And if you found that helpful, make sure you check out the other links that are down in the description to the other 3 parts, the no calculators sections and the other multiple choice calculator section. Good luck on that test, and we'll see you later. Thanks for watching. If you found these videos helpful, you can find other videos in my series, and don't forget the reviews where I talk through a bunch of practice problems. Have a great day.